So this will be the final video on structure and function of the heart, which will cover the ECG calculations and also the very general stuff about blood pressure. So the previous video covered the cardiac conducting system, and this relates to that. So if you don't understand what that is, you'll need to go back and have a look at that video first to make sure that you understand these parts. Now an ECG is what's called an electrocardiogram. So it's shortened to an ECG from the electrocardiogram. Now that'll detect currents that would be generated by the impulses in the heart due to the cardiac conducting system. So when the electrical impulses pass across the heart and the heart contracts at certain points, it would then be picked up, those impulses would be picked up as a current on an ECG. So an ECG looks something like this, and you'll probably have seen it on TV. Now you need to know what each of these parts shows. So this part would be where the heartbeat would begin, and the first part of a heartbeat is the atrial systole. The reason that's small is because the atria are thin-walled and they're not very muscly, so they don't need a huge amount of an impulse to then cause them to contract and cause atrial systole. Then there'll be a big surge, so a large increase in that impulse and that current, and that's because this is where the ventricles are contracting, and this is ventricular systole. Now they need a large impulse because they're really quite muscly and they need to force blood out of the heart. And then what you'll get here, in between the ventricular systole and the next atrial systole, is your diastole, which is your relaxation of the heart. So what you then want to look at is what a whole heartbeat is. So essentially it can be measured from the start of one to the start of the next. So that could be one whole beat. Now you can also measure it in a different way slightly, which would be then you look at the ventricular systole and the peaks of those. So you could talk about it being from here. Now the reason why you can do it from two different ways, and the reason why I'm telling you can do it from two different ways, is because when you read it off of a graph, they'll expect you to be able to read the length of one beat, and you're looking basically to find the one that's sitting on lines, and normally these ventricular systole ones are sitting on a line. Okay, so in an exam question, they'll probably give you a graph that looks something like this and tell you that this period of time will last for a certain amount of time. So say, for example, 0.8 seconds. And then they'll ask you to calculate the heart rate from that. Now how you do this is, you would then get the number of seconds in a minute, which is 60, and then divide that by the length of one beat. Okay, now in this case, that'd be 60 divided by 0.8. When you do that, that gives you 75. Now it's the heart rate, so it's measured in beats per minute. Okay, so that person's heartbeat would be 75 BPM. Now they could then ask you to do this and read off the person's heartbeat and then link it to a calculation based on cardiac output, where you'd be asked then to do cardiac output equals heart rate times stroke volume, and you'd be asked to involve that 75 in a stroke volume calculation. Okay, in a cardiac output calculation. So this could also link to the previous stuff that we talked about cardiac output. Okay, now it's always this procedure, so always 60 divided by the length of a beat. Okay, so I'm going to move on and then talk about blood pressure, which is just a very short part of the course. Blood pressure you will need to know about in terms of what it's used to measure, or what equipment is used to measure it. So it's measured by what's called a sphygmomanometer. Now because of the spelling of this, it'll often be a multiple choice question rather than a normal question. Okay, so it's a sphygmomanometer, and its unit of measurements is millimeters of mercury, so mmHg. Hg is the chemical symbol for mercury. Now, a normal reading for a healthy adult would be what's called 120 over 80 millimeters of mercury, mmHg. Now, these two numbers mean two different things. This 120 is what's known as the systolic pressure. Okay, which is when the heart's contracting. And this lower number is the diastolic pressure. Right, and that's when the heart's relaxing. Now, you might be asked about how this works. You might be given an example of blood pressure in terms of showing you a picture with the cuff round about the arm. So in terms of how this works, the cuff would inflate round the arm. And it inflates to the point where it closes the artery. When the artery closes, that stops or prevents blood flow. Now, obviously, you can't measure blood pressure from that. What you then need to do is allow that cuff then to deflate. And what that allows then is a pulse to be felt, or a surge of blood. Okay, and that's detected by that cuff. And then what that is measured then is your systolic pressure when that heart is squeezing blood out and into those arteries. Okay, and then when the blood is flowing freely without being forced out, that would then be your relaxation pressure, which is your diastolic pressure. Now, what I haven't told you yet is actually what blood pressure is. So just very generally, it is the force of blood against the walls of a blood vessel. Now, when you're measuring blood pressure, it would normally be in an artery, because that's where you would feel a pulse and would feel that typically high systolic pressure. Okay, so in terms of questions that would come up, it would just be what a normal reading would be, or it'd be describing what the two numbers mean or what they represent. So that'd be systolic pressure, or the heart contracting, and the lower number would be diastolic pressure, or the heart relaxing. Okay, and that sums up everything from the cardiac structure and function of the heart.